Today we will solve Leetcode problem number 146, that is LRUCache. Here the problem is saying that design a data structure that follows the constraint of a least recently used or LRUCache. So what is the least recently used cache is? It is actually a cache which has some capacity, and whenever any new data is coming, first it is check that the capacity is fulfilled or not. If not, it will insert that new data into the cache, else it will remove the least recently used data from the cache and insert the new data. Okay, means the which data has used very less, that is removed from the cache. Here it is saying implement LRUCache class. LRUCache int capacity, initialize the LRUCache with positive size capacity. Int get int k returns the value of the key if the key exists, otherwise return -1. Means we need to implement this LRU class. Here is the capacity is given, we need to initialize that. It will be initialized from outside, and whenever some key will be thrown, we will check the cache that the key, if the key is present, we will return the value. If the key is not present, we will return -1. Void put key into value, update the value of the key if the key exists, otherwise add the key value paired to the cache. If the number of key exceeds the capacity from this operation, evict the least recently used key. The function get and push must each run in one average time complexity. So basically it is saying that first we will try to get the value. If its value is present, we will return that, else -1. Put means if the value, this key is present in the cache, we will just update the value, else we will insert a new value, and if it is exceeds the capacity, we will remove the least recently used key. Okay, so this is the one example has been given, that first LRU initializes with 2, then key value pair 1 1 2 is given, 2 2 is given, then 1 is returned, then 3 3 is given, key is 2, so evicts key 2, which cache is 1 1 3 3, evicts key 2, because see, from this example we try to understand if we get any clue. So first we insert 1 1 1 1, next we insert 2 2. Okay, then we will get return 1, so it is returning 1. So 1 is accessed once, so 1 is used once. Okay, then 3 3 is given. So who is now capacity is 2 and my capacity is full. Before that 1 is accessed, so least recently used key is 2, so we will remove 2. So key the cache is now 1 1 and 3 3. Then LRUCache get 2, it is a cache miss, so we will return -1. Then we put 4 4. LRU key is that 4 4, but it is full. So last we have accessed key is 3, because we put that, right, latest used key is 3. So least recently used is 1, so 1 is removed. Now LRU get 1, cache get 1, return it is written minus, because 1 is not present, because cache condition is 4 4 3 3. 3 3 return 3, 4 4 return 4. Got it. So now how will we implement this? See, cache means it's basically hash map, we can do implement that, but the tricks is we need to implement a least recently used hash. Means whenever there is a capacity will be exceeds. So let me write these things. A simple cache is a hash map, but here we need to implement one cache which has some capacity, and when capacity is reached we should evict the least recently used key to give space for new data. And this get and put has to be done on O1 time. Okay. So apart from hash, we need to maintain a data structure where we can store those keys, key values, and we can also modify them in O1 time. So apart from hash map, what are the data structure we can use by which we can modify that in O1 time? Means let's say when 1 comes, we'll insert, 2 come, we will insert, get 1 from the cache, we will get the 1. So when 3 come, then the least one we need to pull, means remove, and we need to insert 3. So the data structure that can help here is doubly linked list. Here we will always insert at head. Means when a new data will come, that will also in the head. If the data, new data and update data, means the put case, that update the value of the key if the key exists, otherwise the key value paired, add the key value paired to the cache if the number of keys exceeds the capacity from the operation, evict the least recently used key. So we'll always insert at head. Means when a new data will come, if we see that data is not exist, we will insert that. If the new data comes, capacity achieved, then new data we need to new data comes, then least recently have to remove. So how will remove that? Least recently removed will be present at the tail. Okay, so for doubly linked list, the least recently used data will be at tail. Okay, so it will be like that based on the usage of the key, the data will be arranged based on the usage of the key. The data will be arranged in the DLL. Means whenever any data that can be asked for to get the value or update the value, that data will automatically comes to my head. Okay, so most recently used data will become in the head, and least recently used data will be in the tail. Okay, so in that way this LRU cache will be arranged. So to maintain the key value pair we use a hash map, and to maintain that ordering we will use one doubly linked list. So let me build the doubly linked list here. Class doubly linked list. It will have two node, variable node. I am taking some dummy node for our operation purpose, node 0, and variable tail as node 0. As I said, we always put the data at the head. So insert at head. Now what is this node? We need to create a doubly linked list node. So class node, and we will use variable key and variable value, that will also be integer. Variable previous. Doubly linked list has two pointer, right? Previous and next, means it can point to yes previous node as well as next node. So that is also node, and prep next is also node. Okay, and one initializer I will add, that will take the key value, key int comma underscore value int, and we will store them here. Dot key is equal to key, and self dot val is equal to value. Nice. Okay, so insert at head, and that will be a node. Now when we will initialize this, then what we will do, this head dot next will be tail, and tail dot prep is equal to head. Initial position, no data, no node has been added, so just like it will be one head, and this is tail, and tail also connect to head, like that. Okay, now when we will always insert at the head, this head will point to the head node, actual head node, and this is the dummy node, and tail will point to the actual tail node. It is we created those dummy nodes for our implementation, ease of implementation. So how will you do that? A new node came, that node dot next will be my head dot next, means which is currently head dot next. Then head dot next dot prep will be my node. Okay, this head dot next dot prep will be my node, and because I am changing that new node as a head node, so head dot next is my actual head node, so node dot next is equal to head dot next. Okay, now head dot next, which is current head node, is previous node will be the node. Now node dot prep will be my this dummy head dummy node. Okay, and this head dot next will be equal to my node, right? Node dot next is head dot next prep equal to node, then node dot prep is my head. Okay, and head dot next is equal to my node. Okay, now function, another function I will write, that remove. What this remove will do, it will remove a node. Okay, remove is very easy. Node dot means we'll just point from the previous node to next node to previous node. So node prep dot next is equal to node dot next. Previous next is pointed to node dot next, and node dot next dot prep will be node dot prep. Okay, what is my previous node? That node will point to my next node, and next node will be previous pointer will point to my previous node. Next I will return that last node of the W linked list, because it will be required when we will remove the last node. Okay, it will be returned as tail dot prep, because my tail is this one. Tail is the dummy node, and it is this previous node is my actual last node. Cool. Now this capacity. First I will write here variable capacity, that is int variable count, also let's say mark it 0 directly. So self dot capacity will be equal to capacity, and we will have DLL, variable DLL, that will be W linked list, and I will initialize this DLL when this LRUCache is got initialized. List this one, and we need an cache or has an actual cache. Is int, and it will take the node as the value. Okay, now get key. So simply you will check that guard let node equal to my cache key. And we will return -1. Okay, guard let node is equal to cache key, else return -1. Got it? Means we will check that my node is present in this cache or not. If it is not present, we will simply return -1. Else, what we will do, our DLL will remove it. Will remove the node. Means at any point it will remove the node, and it will insert it at the top. Mean insert dot head. Insert at head, and it will be node. So from any point we are accessing the cache, this with the key, if this present, that will be recently used. Okay, so it will come at the head. So whichever is recently used, that come at the front, mean head, and which one is least used will go into the tail. Okay, now we will return the value of this node dot value. Okay, so this is the get functionality. It is an O1 time it will do, because remove also O1, insert at head also O1. Nice. Now put. First we will check if let my node is present or not. Okay, So cache, we are using key. If in my cache, if my key is present, so simple we will do node dot value will be value, new value, will update it, and as it is most recently used node now, so we'll do the same. We'll remove the node from its position and insert into the top. Else what we will do, we will check the node is present, not present in my cache. Okay, so you need to insert this node, means this key value pair. If count is less than capacity, we will check that my count is less than capacity or not, then else. But first we will do this one, count is less than capacity. Here what we will do, we will create a new node, simple new node, value. Okay, so node is created, so we need to insert this. So now it is the recently used. Okay, so we have created this node and we will insert this node here at the beginning, and we will count plus plus, we will increase the count. Plus plus is not available in Swift, plus equal to 1. Now if my capacity is full, then it will come in the else block. So that time what we will do, we will remove the last node. As we discussed, this is the least recently used node. So if let last node we will take up, and we will take up the last node as the DLL dot last node. My key is full. Okay, so if it is present, what we will do, we will simply remove it, will not add it again. Then this node can be put outside, and this DLL can be put here, right? Means if DLL is last node, then you will remove it, else we will insert it. Now we will to update the cache as well. See, here we are just getting it, here we are updating with the, when the value key is present, update the value. So now key value is here. Now this cache 1, what is my cache key, that cache key, it is removed from the cache, right? So it's not present. Node dot key will be null. Okay, and here cache key will be node. Okay, so if my count is less than capacity, count plus 1, if capacity is reached, we will take the last node, mark it null, remove it, and then insert the node there at the top. Now let me run this. Let's see what happens. Okay, some here we have mistake 0 because key value pair it is. Okay, now run this. Okay, key value, where I made the mistake. Yeah, oh, it's a value. I need to give value instead of value. Now run. Oh, it's a swift hit.next, this one. This is the swift optional check, an optional chaining we need to add here. Okay, did we make any kind of mistake like that? No. So now run. This one 3,4. Okay, what's the mistake I did? This one, last node dot key. Why the node of yes. Again -1, 3,4. I have removed this node, so this node should be last node. This is the last node is last node. Okay, last node key dot seq will be nil. Last node we should remove, not the this node, because see, I am trying to inserting the node by mistake. I have removing this node. It's had to be last node. Yes. What it is? Yeah, it's accepted. Okay, so this is the code that we are assign the capacity, count is 0, then the DLL cache, everything. If you are want to get the value, we are getting the from the cache, then removing it in and inserting it at the top. And when we are putting it, we are checking that it is present in the cache. If it is present, we are just update the value, removing it from current position and put it on the top. If the value is not present, we're creating a new node, then we are inserting the node to the cache with its corresponding key. If the capacity is not reached, we are just increase the count and insert it to the head. Else what we will do, we will check the last node which is least recently used, and then we will update that key to nil because we are removing this, and remove that node. Okay, so this is the code. Now I will submit it. So this is accepted. Solution is done. So this is the proper code. And now the time complexity and the space complexity. See, here all the operation has been made in O1 constant time. So we can say the time complexity is O1, and as we are using extra hash map, and the capacity of the hash map is the capacity of the LRUCache, is space complexity is order of capacity. Okay, that's it from the problem. So I hope you enjoyed this video. So if yes, please like this video, and if you like to get this kind of video in future, please subscribe to my channel. Thank you.